This is chapter 5.1, exercises 23 through 27 and 29 through 32, page 452. And these are trigonometric identities problems, which can be pretty difficult because sometimes it seems hard to simplify, and sometimes you would go down a track, you're not sure you're on the right track. And here we have secant squared theta plus cosecant squared theta minus quantitangent squared theta plus cotangent squared theta. And we see these squared things here. It should give us a clue that we might be able to use our Pythagorean identities, one of which is, the first of which we're going to look at here is 1 plus tangent squared theta equals secant squared theta. And we're going to come down a couple steps here, and one of the other Pythagorean identities is 1 plus cotangent squared theta equals cosecant squared theta. All right, this first one, if we solve for tangent theta by subtracting both sides of the equation, 1 from both sides of the equation, we're going to get tangent squared theta is equal to secant squared theta minus 1. And if we solve the bottom one here for cotangent squared theta, we get cotangent squared theta equals cosecant squared theta minus 1. So we just subtracted 1 from both sides of each of these equations. And now we can replace tangent squared theta here, actually tangent squared x, and cotangent squared x here. And so rewriting, we have secant squared x plus cosecant squared x minus, and we're going to take replacing tangent squared x with secant squared x minus 1, and next we're going to replace cotangent squared x with, and we have to add between those because that's plus, right? Plus CSC squared x minus 1. And removing parentheses, we're going to have secant squared x plus cosecant squared x minus secant squared x minus 1. Oops. We have minus 1, so we're going to have this as plus 1 here, minus cosecant squared x, and minus negative 1 is plus 1. So we have some cancellations, don't we? We have secant squared x and minus secant squared x cancel each other. Cosecant squared x and minus cosecant squared x cancel each other. We have 1 plus 1, which equals 2. So that should be our correct answer. But just to be sure about that, we're going to go to our calculator. And we see our calculators in degrees. I hope you're able to learn how to substitute. We're going to check for equivalency. We're going to store an angle value. We're in degrees, so put 33, control vars x. So x is 33 degrees. So we enter our expression that we had first. Okay, it's going to be secant squared x. So we go to secant x and squared on the outside, and we're going to add cosecant squared x. There's x. So we put squared on the outside here. And then, let's see, we're going to, after that, subtract, open parentheses, open again, tangent x, and we square on the outside of this. Let's see. I think I have this messed up. Let me go back here. I think we want to go secant squared, and we have to put squared outside of this here. Okay, there's squared, plus, open parentheses, cosecant x. We've got to go outside the x and outside the next parentheses, squared. Okay, I think, oops, squared. There we go. And now we go ahead and subtract, open parentheses again, tangent x, and we have squared here, and we're going to add cotangent squared x plus, open parentheses, cotangent x, and we put squared on the outside, make sure everything is right. I think this is right, press enter. We get 2, so we don't even have, it is equivalent. So now we're sure that this is our correct answer, 2. Okay, next odd numbered problem, 27. We have use basic identities to change expression from one involving only sines and cosines and simplify to a basic trigonometric function. So in this case, we're going to use our tangent identities, and that is tangent theta equals sine theta over cosine theta, and our cotangent identity is cotangent theta equals cosine theta over sine theta. Okay, let's apply that here for number 27. So we have sine x, we'll leave sine x on the outside, and on the inside here, parentheses, we're going to replace tangent x with sine x over cosine x, and we're going to add cosine x over sine x, which we replaced here. So the cotangent x comes here to this one, and the tangent goes to this one in front. And multiplying out, we get sine squared x, which is sine x times sine x, over cosine x, plus sine x cosine x, right, sine x times cosine x, over sine x. Well, we're going to be able to cancel sine x over sine x here on the right one, and so what we have left is we have sine squared x over cosine x plus cosine x, and we'll just say cosine x over 1. So we're going to add these two together, and for that we have a common denominator of cosine x, And so if we multiply through by cosine x, like this, and actually we're having cosine x as a common denominator, and 1 times sine squared x is sine squared x up here, and cosine x times cosine x is plus cosine squared x. And we can go to our first Pythagorean identity, which is, I'm going to write it right up here, sine squared theta plus cosine squared theta is equal to 1. So we can replace this thing up here with 1. So sine squared x plus cosine squared x is 1. So we have 1 over cosine x. And our cosine identity is our secant theta is the reciprocal of cosine theta. So therefore, 1 over cosine x is going to be secant x. And that should be our answer. We're going to go to our calculator and test for equivalency. And so doing that, we have 33 already stored. We're going to take sine x, put parentheses just like they have it here, sine x times, open parentheses, we have tangent x plus cotangent x, let me see, we've got to be inside tangent x, we'll leave it inside here, plus cotangent x, and pressing enter, this will get 1.19. Now we're going to try, we figured out in our problem, didn't we, that secant x is what should be equivalent. So we're going to go in and type in secant x and hope we get the same thing, which we do. So our correct answer is secant x. It's vastly simplified from our original expression. Okay, we go to number 29. And number 29, we have all these trigonometric factors, I guess you want to call them, in a row. And I find that it's most helpful to change these things in terms of sine and cosine. And to do that, we'll need to use sine and cosine. We have the first two. But the next three, tangent theta is equal to sine theta over cosine theta. And secant theta equals 1 over cosine theta. And cosecant theta equals 1 over sine theta. So we're just going to replace these last three. So we have sine x times cosine x, and now replacing tangent theta with sine theta. I want to put sine x, I want to leave it all x. Sine x over cosine x, and we replace secant x with 1 over cosine x, and we replace cosecant with 1 over sine x. And we just cancel out where we can. We have sine x in the numerator here divided by sine x on the right. We have cosine x here on the left divided by cosine x on the right. And what do we have left? We have just sine x over cosine x, which is going to be equal to, looking at our tangent identity over here in the upper right, tangent x. So we multiply all these together, we should get the equivalent of tangent x. And to do that, we go to our calculator again, open parentheses, we have sine x times, open parentheses, cosine x times, open parentheses, tangent x, we put tan x, open parentheses, times, excuse me, now open parentheses, secant x okay, times, open parentheses, cosecant x, and making sure all these are multiplied outright, press enter, we get 0.4694, etc. And the equivalent that we calculated this is tangent x, right? There it is, tangent x, hoping that this is equivalent. So we go here to tangent x, and we get the same thing. So we should be pretty comfortable that this is our correct answer, tangent x. Okay, next odd number problem, which is 31. We have tangent x over cosecant squared x plus tangent x over secant squared x. And for this, we're going to use a common factor between these two terms, and that would be tangent x. So we pull out the tangent x, and we're left with cosecant squared x. Nope, I got this wrong. Nope. Okay, we pull out the tangent x times 1 over cosecant squared x plus, when we factored out the tangent, 1 over secant squared x. And we should recall that sine x, or we'll put, say, sine theta equals 1 over cosecant theta, and cosine theta equals 1 over sine theta. So accordingly, we can multiply tangent theta, tangent x rather, tangent x times, well, 1 over cosecant squared theta is going to be sine squared theta. So sine squared x plus, and 1 over secant squared x is cosine squared x. And the first Pythagorean identity, which is sine squared x, sine squared theta plus cosine squared theta is equal to 1. So we can replace all this here with 1. So we have tangent x times 1, which equals tangent x. And so we can go test out our answers, going back to our calculator, and if we get a fraction here, control, we have tangent in the numerator, x over cosecant squared x. So we go to cosecant. Before that, let me escape here. Throw parentheses. We'll go to cosecant x, and we'll put squared outside. And we're going to add, we get our, get our fraction here, tangent x over secant squared x. Open parentheses, get the secant, yeah, that's x. When we square that, it's going to go down position here. And we square outside here. And then we press enter, and we get 0.469. That's similar to tangent x, right? We already calculated that for the last problem. And this is our answer already, tangent x. So we know that our answer here is tangent x. Anyway, these are the odd number problems. Pretty challenging, a lot of these trigonometric identity problems, because you don't know a lot of times where you're going. But using a calculator, you can check these to make sure you get your answers right. And I say to you, good luck, and thanks for viewing.